Hello. It is just like I am there. Aren't you so excited? So, I hope this video works out okay. Um, if you have any questions, you'll be able to ask me on Monday. Basically, I did not finish all of the notes. So, for a little bit of the class, okay, I said Monday, but I mean Tuesday. Tuesday is the next B day. You can ask me questions on Tuesday. So I did not complete all of the notes in this video, okay? I did about 3/4 of it, all right? What I'm going to do is I am going to finish the notes on Tuesday. Now, with the portion of the lesson that you see today of 14.5, you should be able to complete half of the homework, all right? The homework is 8 questions long, all right? So you can do 1 through 4. Watch the video, jot down some notes, help each other out, and then I think you could finish 1 through 4 today in class before you leave. Come back on Tuesday. I will show you the other portion of the notes, and then we will do 5 through 8 on Tuesday, all right, of the homework. All right, that's the plan. Email me if there's any problems. All right. Have a great weekend. Make good choices. Complete your homework, please. And I'll see you next week. Bye. All right, so what we're gonna cover today is section 14.5. So I am going to do some notes today, right? And just like I told y'all last class, I'm gonna do the notes. Hopefully you enjoy this video. I'll try to make it as short and sweet as possible, but still informative, just as if I were there. So, 14.5 is over what we call the area problem. So the idea of this, all right, is basically we're talking about the beginning stages of what is called the integral. All right, what an integral is. All right, so I've been mentioning, and I've mentioned a couple times, there's kind of 3 main topics that we talk about that you study if you go into calculus. All right, and one of them is the limit, which we've been doing lots of limits, all right, in class. The second one is the derivative. Okay, that is when we are finding the slope of the curve, all right, and that is basically what we did in 14.3, the long way though. Just wait till I teach you the shortcut, all right? And then the third thing is what we are starting today, which is called the integral, all right? The idea behind an integral comes from when you have some sort of function that is graphed. So I'm gonna graph just some sort of like crazy polynomial curve, right? I don't know what it's the graph of. We're just go with it, all right? And they say something like we want to find the area under this curve from x equals 0 to x equals 5, something like that. So obviously right here, that's where x is equal to 0, and I'm just going to say 1, 2, 3, 4, and 5. Okay, there's x is equal to 5. So what they want me to do is basically to section off, right, that area of the graph that's between 0 and 5, all right, and find the area that is in between that graph, okay, and the x-axis right there, all right, find that area. Now, in geometry, right, we did area of shapes, okay, and you could just plug stuff into a formula to get the area, all right? We have some kind of crazy graph, some crazy curve here, and there's not gonna be an area for that. So what we do, and the main idea of this, what we're going to be doing is we're taking, all right, that space and we're splitting it up into rectangles, all right? And we want our rectangles to all have an equal width. So what I'm gonna do is I'm just going to make 1, 2, 3, 4, 5 rectangles, all with a width of 1, since that's already easy and I just split it off like that. So to draw my rectangle, I basically just stretch up my side here till I hit the curve, and then I cut over. All right, so that would be my first rectangle. I'm gonna draw in a second rectangle here. Now this one, I hit the curve kind of low. We're still just gonna go with it, and that rectangle is gonna be a lot shorter. Okay, I've got a rectangle here. I hit the curve. I sketch the top of that rectangle. Here's my fourth rectangle. All right, this one's actually going above where the curve is. All right, and then my fifth rectangle to right there, and then I flatten out the top of it. All right, so I have rectangle A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. And the main idea behind this is that the area of rectangles is easy to get. Okay, so we just calculate the area of those 5 rectangles, add their areas together, and that is going to be an estimate, all right? Not an exact number, but just an estimate, an approximate value for the area underneath this curve, okay? So this is not gonna be hard, but it might be just a tad tedious just because we are finding the areas of all of these and then adding them together in the end, okay? So that was just to kind of introduce what the main idea of this is. Now I'm gonna show you the first example. Okay, here we go. So we are going to estimate this area using rectangles. It says use rectangles to estimate the area under the parabola y is equal to x squared. Okay, so that's what we have the graph of right here. Right now we know we've dealt with parabolas a lot before, all right, even before you were in pre-cal. All right, a parabola does have another side to it on the negative side, all right? However, they only want us to find the area from 0 to 1, which is why we are only looking at those x values, all right here from 0 to 1, and this side of the graph. Luckily, they have already drawn in the rectangles for us. And so the first thing I want to notice is what the width of each rectangle is, all right? They divide it up evenly so that the width is the same, all right? And you can tell that the width of each of these rectangles is going to be 1/4, all right? Now, just like I was saying earlier, I'm going to label these rectangles A sub 1, this will be A sub 2, A sub 3, and A sub 4, so that when I'm finding the area of them, okay, I can differentiate which one I'm working with. All right, so first we are going to find the area of A sub 1. Now, we know that the area of a rectangle is going to be the width, in this case, times the height of it, all right? The width of it, we already know, is 1/4, and we are going to multiply that times the height, which is unknown at the moment, all right? How we're going to find the height of it is we are going to find the coordinates of that point. Now, the x-coordinate for that point is 1/4. The y-coordinate, if I knew that, right, the y-coordinate, that would be the height of the rectangle, all right? How do you find the y-coordinate for the point at x equals 1/4? Well, we already know the x value, okay, and we know the equation that gets us this curve, and that point happens to be on the curve, all right? So I know the equation is y equals x squared. The x value, right there is 1/4. So if I do 1/4 squared, which equals 1/16, just square the top and bottom number, all right, that's going to be my height right there of that a sub 1 rectangle. So I have 1/4 times 1/16. Now, I'm not going to multiply those right now. You'll see why at the end, okay, once I find write out their areas. All right, so now we're moving on to a sub 2. Again, the width of that is going to be 1/4. All right, I need to get the height of the second rectangle. Now, the second rectangle's height, right, is the y value of this point, okay, where its x value is 1/2. So again, I can plug in that x value, 1/2, into the y equals x squared, all right, to get its y value. 1/2 squared is 1/4, so the height of a sub 2 is 1/4. And we just continue like that. 2 more rectangles to go. So a sub 3, the width, 1/4. The height we will find by plugging in the x value into y equals x squared. The x value for a sub 3 that you'll plug in to get the height of that, right, is going to be 3/4. So we do 3/4 squared. Square the 3, 9. Square the 4, 16. 9/16 is our height. Okay, last one, a sub 4. Now, actually, if you look closely, we don't even have to plug in our number for a sub 4 because they went ahead and marked this point for us. It's the point 1, 1. Okay, and so the y value, which is what we were finding earlier, we already have it. The y value is 1, so that's the height. Again, the width is still 1/4. All right, so the idea, like we said behind this, is to find all 4 areas and then add them up, right? The area, the estimate of the area of this curve, all right, is going to be a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. All right, now this is going to be kind of long, and you won't have to write this out every time. You'll see the shortcut in just a second. All right, so a sub 1 is 1/4 times 1/16 plus 1/4 times 1/4 was a sub 2 plus 1/4 times 9/16 for a sub 3 plus 1/4 times 1. Okay, now these all have the number 1/4 in common, all right? And I left it like that so that we could see that, all right? So basically what we can do is factor that 1/4 out to the front. So whenever you're finding the area, right, it's gonna be whatever your width is, in this case 1/4. And if you factor that out of each piece, what's left is 1/16 plus 1/4 plus 9/16 plus 1, okay? Basically, what you're going to do in the shortcut is that you do the width times the heights all added together, okay? These are all 4 of the heights of the rectangles, but added together. All right, so you can go straight to that step in like a future problem now that you know that. The width at the front times the heights all added together. At this point, you would use a calculator and plug that in. So hopefully you can see this on the screen there. Okay, what I'm going to do is I'm going to do 1/16 plus 1/4, which is 0.25. So that's just shorter for me to type it in, plus 9/16, okay, plus 1. So those are my heights all added together, which gives me 1.875. All right, so the area is equal to 1/4 times 1.875. All right, I'm going to go ahead and multiply that times the 1/4. That was the width. And I get an area that is about 0.46875. Now, remember, area has units. Obviously, we don't have like centimeters or feet or anything like that in this problem. So we are just going to call it units, and it's squared since it is an area. All right, that's our area. Now, something I want you to note is that when in the picture, you can see that our rectangles, right, all go way over the curve actually in this one. I mean, not way over, it's not going to be that much, but this area, this estimate that we found is actually an overestimate. All right, it's probably more than what the actual area is, okay, because of the fact, right, that these rectangles more than cover the area that we were really trying to find. Okay, the difference between this picture, okay, and the one over here, all right, is that they've drawn these rectangles over here, and you can see that it doesn't even cover, all right, all that space under the curve. And so this one is going to be an underestimate. Right? The other difference is what we did on this side was called use the right endpoints. Okay, when you use the right endpoints, what that means is that when you look at these rectangles, right, it was this point right here that's actually on the right corner, not the left, right? The right corner that represented the height of our rectangle, right? The right corner as opposed to the left was the height of our rectangle. And that's part of the reason in this one that our rectangles went over the curve, okay? Because the right point was in a higher position than the left point was, all right, on the curve, okay? So, on this one, they're using the left endpoints. Okay, so on this one, we've got technically a left endpoint right here at 0. Okay, the thing about that is no matter what the width is, if the height is 0, then the width times the height is 0. So basically, you know, there's a rectangle, there's a non-existent rectangle right there that we can't even draw because the height of it is 0, right? And that's why there isn't one right here. Okay, so our first rectangle, a sub 1, okay, on this side, right, the height of it is coming from the left corner, all right, of the rectangle. Now notice these rectangles, this is the same problem, all right, and so the width of them is still 1/4, all right, so we've got a sub 1, a sub 2, and really only up to an a sub 3 in this one because the fourth one is that non-existent rectangle right there. All right, now if we find the area of a sub 1, we have the width, 1/4, right, times the height, okay? The height of this one, right, is coming from this x value of 1/4, and we would get the height the same way we did on the other side, right? So if this x value is 1/4, we would plug that in to the y equals x squared, which we actually did over here already, so you don't really need to do it again. You've already done the work, okay? So that 1/4 squared was 1/16, so the height of that one is 1/16, all right? Then we go to a sub 2, we've got 1/4 times the height. All right, the height of a sub 2 is going to come from this 1/2. You plug in that 1/2, square it because of y equals x squared, and you get 1/4. Okay, then a sub 3, the last one on this side, right, is actually coming, the height of it is coming from this 3/4, all right? We don't actually use the 1, okay, because we don't have a rectangle drawn, all right, that goes all the way up to that point, all right? There's not a rectangle there. So 3/4 is the last one, width is 1/4. When we plugged 3/4 into the y equals x squared, we got 9/16 right here. And so this is 9/16. We're gonna add these up. A sub 1 plus A sub 2 plus A sub 3. But instead of writing it all out like I did right here, right, you can skip to this step where we know you're going to do the width times all the heights added together. All right, so the area is going to be the width, which is still 1/4, times the heights added together, 1/16 plus 1/4. Plus 9/16. All right, we're gonna add those together and see what that is. Though that would be, let's see here. 1/16 plus 1/4, which is 0.25. All right, plus 9/16. I don't know why I did this differently than the first time, but anyways, you get those added together is 0.875, and then multiply with your 1/4, okay, which gives you an area when you calculate it from the left end points, all right, you get an area of 0.21875, okay? Now, note in the beginning, we knew this was going to be an underestimate, all right? Whatever the actual real area under that curve is, the exact number, it's more, all right? It's got to be something more than 0.21875, all right? But over here, we had an overestimate at 0.46875. So although we don't know the actual area of this exactly, we do know what it's between, right? We know that it's something bigger or greater than 0.21875, okay, but less than 0.46875. And I'm not going to get more specific than that. I'm just going to leave that as a range. All right, now you're not going to have to be finding the area of curves from the left side and the right side always. We kind of default normally to using the right end points and just calculating that one and not doing the left. All right, so I'm going to show you another one like that in just a second. All right, so next example. What if you were not given the definition of the function or the equation of the function? So in the last example, we knew that the graph that they had drawn was part of the y is equal to x squared curve. Here, they've just drawn in a piece of some sort of graph, a piece of a curve, all right, and asked us to find the area. But what we're not going to be able to do is plug in x values to equation to get the height because we don't have the equation. They just told us y equals f of x, which is not very helpful. All right, but here is what we do know. All right, obviously we have the graph. They did give us a grid, so it's easier to tell where things are on the graph. We are going to make 6 rectangles, and we are going from 0 to 12. So that's what is drawn here, right? From 0 to 12 is where we are stopping, and we are finding that area under the curve there, okay? So how do we set this up so that we can estimate the area? Well, if we're making 6 rectangles, we know we have 12 along the bottom, right? 12 divided by 6 means that each of our rectangles are going to have a width of 2. So one of them will go from 0 to 2, 2 to 4, right? 4 to 6, 6 to 8, 8 to 10, and then one of the rectangles from 10 to 12, right? We are going to go ahead and use right end points because that is actually the norm, all right? So instead of going from the first number up to draw our rectangle, okay, I'm gonna go from what would be the right side of the rectangle, so at 2, I'm gonna draw straight up till I hit the curve, okay? And then right there is when I'm immediately gonna cut over to the y-axis, all right? Now, obviously, the width of that is 2. The height of that, we're just gonna have to estimate, all right, by looking at where we are on the y-axis. So here's 8. 9 is slightly above where we are, so I'm gonna estimate that to be like, I don't know, 8.8. And I'm gonna write the height right there, just so I remember and can go back when I find the areas later. Okay, that's a sub 1. All right, next rectangle, I'm gonna go over to 4, draw straight up till I hit the curve, cut over. All right, and I want to estimate where that is on the y-axis. That looks actually slightly just above 8. All right, so let's say 8.2. I am definitely just winging that, estimating. That's what this is, okay? So that's going to be a sub 2. All right, a sub 3 will be right here. Go over to 6, draw straight up, hit the curve, flatten out our rectangle, okay? Look over to the y-axis to see where we are. That looks about a 7.2-ish to me, just above 7. All right. Our fourth rectangle, I go straight up to the curve, hit the curve, turn to flatten it out, and that one looks dead on right about 5, 6. Okay, so we're just gonna use 6 even for the height of that one. Okay, and then here's our, that was a sub 4. This would be a sub 5. I go up, I hit the curve, I turn to flatten it out. That looks right about exactly at 4. So let's use 4 for that height. And then the last one is at 12. Now you don't get to go up very far before you hit the curve. And so you still have to flatten it out right there. Obviously that rectangle is much shorter than covering the actual space. But again, this is an estimate. It'll be okay. And it looks like the height of that one is going to be right at 1. Okay, now remember the width of all of these, right, are 2 units. All right, so a sub 1 is, or actually, let's just jump to the area, all right? Finding the area, what we know happens is that we have the width in front, the width is 2, times all of the heights added together, all right? Our heights, we labeled at the top so we could remember what they were. We had 8.8 plus 8.2 plus 7.2 plus 6 plus, oops, I ran out of room, 4 plus 1. All right, so first thing I'm going to do is add those together using my calculator, the handy dandy calculator. 8.8 plus 8.2 plus 7.2 plus 6 plus 4 plus 1. All right, 1, 2, 3, 4, 5, 6 numbers because 6 rectangles, so 6 heights. All right, gives us 35.2. and we multiply that times 2. All right, 35 times 2 should give you 70.4. All right, and that is our estimate units squared of the area under that curve.